Hello everyone. Today we'll talk about the solution to the problem two best non-overlapping events. Typically in problems like this, including events, so including intervals, there will be some sorting involved. That might be sorting based on start time, sorting based on end time, maybe sorting based on both at the same time. That is, we split every interval into two events, the event of interval starting and the event of interval ending. And it's because it's natural to reason about those problems, in many cases, in a sweep-line fashion, where we just we imagine that time flows by, right? And as the time flows, intervals start, intervals end, and we can keep track of some values, calculate something, and get the result after we go past the last event. And indeed, this will be what gives us a solution here. Here we want to get at most two non-overlapping intervals and maximize their sum. So if this was only one interval, we actually wouldn't have to sort anything, we would just get the maximum value of all the intervals. And here, the naive approach would be to, of course, notice that the best solution is for every possible interval to, if we take that interval, take the maximum value from all the intervals that do not intersect it. And by not intersecting it, we can look at it as taking this interval and the best from all the ones that are to the left of it completely or to the right of it completely. So that's the naive approach. And one thing that we can use to simplify this is that if we do that, then for every pair of intervals, we'll be calculating their value twice, because we'll be calculating their value for the left interval and taking the right interval then, and for the right interval, we'll be taking the left interval. And if we want to eliminate this redundancy, we can, for instance, consider events, so we go through all the events, but we consider that this event that we're looking at is the first event of the pair. So we only look at events to the right of it. We still look at every possible pair because every possible pair has a left event. So we'll notice it when looking at that event as the left event. Okay, so now we're closer to a solution and how to make that solution feasible, because right now this would require a quadratic amount of work, because we have to, for every interval, look through all the other intervals and see those that do not intersect our one. And it would be very convenient if our ordering, which I mentioned at the beginning, would help us in this situation. And indeed, it can help us, because if we order the events properly, we can make sure that the set of possible events that are to the right of our current event monotonically gets bigger and bigger. In other words, we never remove events from that pool. Because if we have that pool that always gets bigger and bigger, then we can just keep track of the maximum value in that pool. And we can be safe in that maximum value will never disappear. The interval that allows it will never disappear. And that can be achieved, for instance, by making sure that we look at events in the order of their end time, let's say, and we start by the event that ends as the last event, so that ends the furthest in time, and now the set of events to the right of it is of course empty, and we'll be going backwards through all the events, and maybe at some point we reach an event that ends, let's say, at time 80, and suddenly one of the previous events that we've looked at, that starts at time 85, is to the right of it, and we can consider it as the second event. And when we have that, the solution just becomes, after sorting, simple two pointers. We go with one pointer for all the events that are the left event of the pair, and as necessary we add right events of the pair into the pool, and by adding them into the pool, it just means taking the maximum of their value and the previous best value. And one thing that we need to get here is that the condition, as I mentioned, is that we have to have the event start after our event ends. So we have to look at our events sorted by their end time to make sure that the pool of the events to the right never gets smaller. But we have to add things to the elements, to the right elements, based on their start time, which means that we essentially have to have our events list either sorted in two instances by start time and by end time, or combine the two into a single list of events of starting and ending intervals. Okay, so I elected to just choose two different sorted arrays. So we'll be having events sorted by start time and events sorted by end time. We'll be iterating over the events sorted by end time backwards. Our result at the beginning is just the best value of all the intervals that we have. The next free will point to the next possible free event from those sorted by start time, so to the right event. And this is the best of the currently seen right events, the best value. So for every event, we'll be taking the result to be the maximum of the previous result and the value of this event plus the best event to the right of it. And maybe some new events are now possible to add to the right of it. So before we do that, we look. While there are still some events that we can add to the pool, and they start, so they zero after our event ends, because they have to be to the right of that event, we can add them to the pool. So the best, so this rem, the best value from all the right elements, is the maximum of what it was previously, and the value of that new right event. And of course we have to increment next free. And after going through all that, we have indeed looked at every possible pair, so you can just return the result, which is the maximum sum of their values.